Hi everyone, I am Devi, Professor of Electronics and Communication Engineering, Kogni College of Engineering and Technology. In this video lecture, we are going to learn about convolutional codes and how to categorize convolutional codes into tree, list, and code structure.
Can be able to understand the principle of convolutional encoding. Convolutional coding is done by combining a fixed number of input bits. That is, it's a widely used coding method which is not based upon block of bits. But rather than using block of bits, output bits are coded or determined by the logical operations on present in bit streams and a small number of previous bits. The input bits are stored in a fixed length shift register and they are combined with help of modulo 2 adders. The main applications of convolutional coding is the deep space applications in wireless communication systems. The operation is equivalent to convolution and hence it is called as convolutional coding. Whenever a message bit is shifted to position m, the new values of x1 and x2 are generated depending upon m1, m2. The convolutional encoder consists of one shift register which having the input coming bit which is represented by m and the stage of flip flop which is represented as m1 and m2, and it uses the modulo 2 adders. So x1 is the inputs from the flip flops and x2 is the inputs which is connected to second modulo 2 adder. So x1 and x2 are two modulo 2 adders. The bit, the m is the message bit or current bit. It represents the part of shift register. The advantage of convolutional code is this code is a popular error correcting code method which is used in digital communication systems. The convolution operation encodes some redundant information into transmitted signal, thereby improving the capability of the channel. The operation of the convolution encoder can be explained in a equivalent transmission method, that is equivalent three methods. One is state diagram method, tree diagram and tree list diagram. In this encoder, convolution encoder, the output switch represents samples x1 and x2. The shift register shifts the contents of m1 to m2 and contents of m to m1. So next input bit is then taken to and stored in the current bit position m. x1 and x2 are generated according to the combination of m, m1 and m2. So as per the given diagram, here m is the current incoming bit, m1 is the current incoming, m0 is the second stage of flip flop and mn minus 1 is the last stage. So here we have two modulo 2 adders. In the top modulo 2 adder we have connections from m1, m0 and m minus 1, and bottom two modulo 2 adders here n2 is the second modulo 2 adder, n1 is the first modulo 2 adder having three connections, n2 having only two connections from m0 and m minus 1, and n3 having connections from m1 and m minus 1. So depending upon the connections from the inputs, we can write the equations of m1, n2 and n3. So n1 is m1 modulo 2 addition with m0 modulo 2 addition with m minus 1, and n2 is m0 modulo 2 addition with m minus 1, and n3 is m1 modulo 2 addition with m minus 1. So the code rate of convolution encoder is determined by r equal to k by n. R is the rate of the convolution encoder and k is the number of message bits coming at a time to the first part of the encoder current bit position, and n is number of modulo 2 adders. The convolution encoder processes the information sequence continuously. N bit encoder output at the particular time depends not only the k bit information sequence but also m previous input blocks. Convolution encoder has memory which is in the order of m. The set of sequences produced by a k input n output encoder of memory order m is called as nkm convolutional encoder. The values of n and k are much smaller for convolutional codes compared to the block codes. And in case of convolutional encoder, we have another one parameter which is called as constraint length. The constraint length of a convolutional code is defined as the number of shifts over which the single message bit can influence the encoder output. It is expressed in terms of message bits. So here, whenever a single message bit coming to the input and under which shift it reaches the output position should be calculated. That position is called as constraint length. So the dimension of the code is represented by n comma k. So convolution encoder n is number of model 2 adders and k is the input message bit, n comma k is the dimension of the code word. So here we have one quiz question based upon convolution codes. The method used for representing convolutional encoder are: first one connection pictorial, second one state diagram, third one tree diagram, and fourth one all of the above mentioned. The answer is all of the above mentioned, because we know that we can represent convolutional codes as different ways. One is state diagram, tree list diagram, and tree diagram, etc. So these are the ways to represent convolutional codes. In the tree diagram, we can calculate the tree list and Viterbi algorithm decoding. So answer D is the correct one. So the explanation I said, there are several methods for representing convolutional encoder, that is pictorial, connection, vector, polynomial, state diagram, tree list diagram, tree diagram, etc. These all are the way to represent convolutional codes. Thank you.